Alright, so we're going through our Unit 5 review here for Algebra 1. First question here, we're starting with identifying the range and the domain. So let's remember here that range is signifying our y values and domain is our x values here. And again, all these are given us as ordered pairs, so x comma y. Now, when we're looking through this, we want to make sure we're not repeating anything, right? We only need to list values once. So if I'm looking for my range, I'm looking at the values of 8, negative 12, 1, 0. And again, we have the repeating 0, but we don't need to list it twice. So our answers are given in increasing order. So if I look here, I have a negative 12, 0, 1, and 8. So C is my correct choice. Looking at number 2, for my x's, I have 2, 4, negative 4, 5, and negative 5. So if we go in that increasing order, I'd be at negative 5, negative 4. So I got negative 5, negative 4. So looks like I'm, well, narrowed it down to a couple of these at least. I'm on B or D, and then I'd have 2, 4, 5. So negative 5, negative 4, 2, 4, 5. So we're looking at choice D. Okay, writing as a table here, we're just making sure the x's are with the correct y's. If we're looking, the only one that even remotely matches up here, so with that 2 going with the 8 would be choice D. Alright, number 4. So we have the score on the final test depended on the number of study questions that the student completed. The final test score is D. So remember, the dependent variable is what we're measuring at the end. It's how we gauge how well or unwell something may have worked. So in this case, that final test score here, that's our dependent variable. It's dependent on how much the student studied. Look at number 5. An investigation was done to see if keeping the lights on for different amounts of time each day affected the amount of the monthly bill. Keeping the lights on is I always like to find the dependent first. So what we're gauging this in, what we're measuring at the end, is that monthly bill. So the monthly bills are dependent, and thus keeping the lights on is our independent. Okay, we're deciding if the given relations are a function. So here, the key idea is that each x only goes to a single y value. So we have no repeating x values. In this case, let's see, no, 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 no. So this one is a function because each x only goes to one y. Here, we can check. We look here, we see we have a repeating x value. So the 1 goes with a 2 and the 1 goes with a 4. So that's not going to be a function. On to number 8, we see each x value only has one arrow leaving it. So we're good to go. This one would be a function. Number 9, same thing here, we look. Each x value only has one arrow exiting it, so it goes to only one y value. Therefore, it is a function. When we're given a graph, we're looking at the vertical line test. So, essentially, if I could draw a vertical line at any point on the graph, and excuse my poor drawing abilities, and hit the graph twice, it would not be a function. So looking for those repeating x's again. Here, we see that it is all good, so it is a function. Over here, if we're looking, so we have our scatter plot, and then right here I see I can draw a vertical line and hit 2 different dots. Similarly, I could also do it here. So if it occurs in at least one place, it would not be a function. Okay, so suggested order here. If I'm looking at my graph, I always like to start with the stationary. So anytime we have a horizontal line here with a slope of 0, that's going to be a stationary. So I'm going to go ahead and get rid of C first and mark out my stationary. So again, not necessarily need to be done in order. Okay. Now, the next thing I have to get rid of is D. So D is a curve. Anytime we have a curve, whether it's going up, down, whatever it may be, we have a change in speed. So it's either increasing or decreasing. So when we look at my choices here, since it's going upward, we're increasing speed. So we've gotten rid of C and D. Now I'm looking at A and B. Okay, those are going away because the distance increasing as time goes on. E is going downward, so it's like it's going back to start or returning home. So I'm going to get rid of E and X for returning to start. Lastly, we see our choices are slow and fast steady speed. So if we're comparing A and B, since A has a more vertical slope, so it's increasing faster, that represents a faster steady speed. Steady just means it's a straight line, it's not curved such as D. So here our fast one is A, and our slow steady speed is B. Alright, another graph. Okay, so for these first couple here, the first three, it looks like we're choosing a part of the graph that represents the story. So we have Sam had to turn around and go back home to get his backpack. Now if we're looking, turning around means we were going somewhere and came back. So if we kind of look at this graph as a story about Sam, here Sam would be leaving wherever they started. So maybe they started home. So this would represent Sam leaving home. And then we stop moving here. So that stationary, that horizontal line represents they stopped. And then this portion of the graph would mean returning home. D would be perhaps staying at home looking for something. And then E represents leaving again. So at this point we're leaving again. And then F we're stationary, so we arrived wherever we were going to. So for this one, Sam had to turn around to go home. That would be right here. So C would represent them going home. Stopped walking to school and called his mom to see if his backpack was left behind. Well, that would be B here. So we walked towards school, we stopped to make that phone call. Sam initially left home and began walking to school. So initially means that's when we first started, so A would represent that portion. This would be the second time walking to school. Okay, how long did Sam stay at home when he came back for his backpack? So we left, we left, called, got home. So D is going to represent when we were at home. So if I look at the time axis here in our axis, it looks like I stayed from 13 to 16 minutes. So that means 16 minus 13, we were there for 3 minutes. How far did he travel the second time he left his house? Well, here's the first time I made my call, I came home, hung out at home, and then here's where I left the second time. So, if we're looking for how far he traveled, let's see, we started at a length of 0, or a distance of 0, and then we traveled to here. So it looks like, well, we're in between 4 and 6, so that would be 5 miles. Last one, what is f of 4? So this is saying, like, what is f? So what is the value when x is equal to 4? So f of 4. If I'm looking at 4, and I go up, we're right here on our graph. So my f of x is going to be 8. Alright, moving down. So given the functions f of x and g of x as they're written, evaluate g of negative 3. Since we're only asked about g, g is all we actually need. So g of negative 3. Remember, when we plug in, always use parentheses. So I'm going to substitute that negative 3 wherever I see an x, and I'm writing it in parentheses. So at this point, the calculator, if we type this exactly as it looks, we'll be good to go. Or if you want to do it kind of by hand here, so negative 3 squared is 9. Negative 2 times negative 3 is positive 6. And plus 3, so I'd get a final answer of 18. Okay, we have g of x plus f of x, so we're not subtracting, so I don't need to switch any signs. So g of x here is negative 5x plus 3, and then f of x is 2x minus 7. So I just need to combine my like terms. So negative 5x and 2x would give me negative 3x, and then 3 and minus 7 give me a minus 4. So my choice would be A. Here, again, I would suggest doing these two independently and then adding them together at the end. So let's figure out g of negative 4. So for this one, it would be negative 5 times negative 4 plus 3. Evaluating that, we'll end up with, well, that would be positive 20 plus 3 gives me 23. F of 4. So I'm going to use my F equation here and plug in 4. This one. So 2 times 4 is 8, minus 7 is 1. So when I add these two together, I would get 24. Alright. Here we have a g of x equation. We're told if g of x is for negative 43. So that means I'm plugging this negative 43 in here to find out what x is. So I would have negative 43 is equal to negative 6x minus 7. So if I add 7 to both sides here, that would give me negative 6x is equal to, we would have negative 36. Sorry, it's a bit early in the morning right now. Alright, so I'd add that 7 to both sides, negative 43 plus 7, that gives me negative 36. Lastly, we divide both sides here by -6. Negative divided by negative is positive, so my answer here is just 6. Alright. Okay, write the relation as a set of ordered pairs. So that means I'm going to take each of these points and just write down the xy coordinate. So we got our nice little set brackets here. First ordered pair, I have 2, 8. Then I have 4, 12. So notice I'm just writing the hours of the x-axis first. This is my x's, this is my y's. Then I have 6, and it's between 2 and 4, so it'd be 3. So 6, 3. I have 8 and 10, so 8, 10. Then it looks like I have 10, 2. And lastly, I have another point up here, so 10, 8. Alright, is our mapping. So we have our two nice little blob things here, circles, blobs, whatever we want to call them, ellipses. So I'm going to write down all my x values here. So I'm going to throw my x's, you can call it domain and range, whichever way. So I'm just going to throw them in the order I'm given. So 2, 4, 6, 8, and 10. And again, I don't need to write it twice because it's the same number. And then my y values, let's say I have 8, 12, so I have 8, 12, 3, 10, 2, and 8. And again, I don't need to write the, so 8, 12, good, 3, 10, 2, and I already have an 8, so I'm not going to repeat it. Alright, now we just need to make our connections. So 2 goes with 8, so I'm going to throw an arrow over there. 4 goes to 12. 6 goes to 3, 8 goes to 10, so I'm just reading up the pairings here. 10 goes with 2, and then 10 also goes with 8. So this would be another example here. Since I see this has 2 arrows coming out of it, this would not be a function. And then lastly, writing it as a table. Here we just have our x and then our y. So I'm just going to, again, kind of match those up here. So writing them vertically, I have 2 and 8. 4 and 12, 6 and 3, 8 and 10, 10 and 2, and then here we actually do write it twice just because that's how the table functions, so I have then 10 and 8. Alright. Okay, we have another evaluation here, so given our f and g, we're told to evaluate f of -1/2. So I'm just going to plug into here. So I'd have negative, and then I use parentheses again when I substitute, -8. Okay, so this is another one I'm going to suggest we utilize a calculator for, just to avoid any type of typological errors. So again, I would suggest a calculator. I'm just going to do it by hand in case you wish to do it that way. So negative times negative gives me +1/2, and I have -8. To combine these, I need like terms, right? So if I wanted to make this divided by 2, to get that common denominator, that means I need to multiply the top by 2 as well. So that would give me 1/2 minus 16 over 2. And then 1 minus 16 is -15, so it'd be -15 over 2. So again, you could give me this as either a fraction or as a decimal. Alright, moving on. Alright, so we're given our two functions. Our first one here, we want to do f of x minus g of x. So remember, with subtraction, the order really matters here. So my f is 4x plus 9. Now I'm subtracting, and again, we want to think of the second term being in those nice brackets because we got to distribute. So my g of x is -6 minus 5. So when we think about that negative, what it does is it distributes a -1. So it flips those signs around. So that would give me 4x plus 9. Negative and negative would be a plus 6x, and then negative and negative would be plus 5. Combining my like terms, so I have my x's, so that would be 10x. And then my constants, my whole numbers, well, 9 plus 4 gives me plus 14. So that would be our answer. Alright, number 32. Again, we have these two different functions, and we have a subtraction as well. So I'm going to go ahead and write this out all together. I'm going to use blue for my f. So my f is 4 times negative 3 plus 9. So that's my f. Then I have this minus symbol, so I'm going to go ahead and throw that in there. They're nice big brackets. Then I have g of 5, so I'm going to use green for that one. So g of 5. So then I have negative 6 times 5 minus 5. So again, you technically could just use parentheses here for the brackets. Again, we've talked about this in class. But again, if you do it kind of separately, it helps out. So if I type just this first bit in the calculator, that would be negative 12 plus 9, so I'd get negative 3 for this. And here I have a minus. I'm going to use parentheses instead of brackets now, just so we can make it a little more calculator friendly. And then evaluating this green portion in the calculator, I'd have negative 30. Negative 30 minus 5, so it'd be negative 35. Lastly, now, if we just typed all this part in the calculator here, so we'd have negative 3 plus 35, because the negatives will cancel out, right? They make a positive when we multiply. So my final answer is going to be 32. And again, if you just used parentheses here, you could literally type this entire first thing in a calculator if you did it just as it looks, and we'd be good to go. Alright, last couple here. So, for this one, we're told that g of x is negative 43. So we're going to plug that in for g of x and solve for x. So I'd add 11 to both sides. Negative 4x. Okay, so negative 43 plus 11, so that's going to give me negative 32. Dividing both sides by negative 4, well, negative divided by negative is definitely positive. So I'd get x is equal to 8. Over here, we're told f of x is negative 108, so I'd have negative 108. Negative 6, x minus 3, and we're finding x, so I'm going to distribute first. And then negative 6 times negative 3 plus 18. Subtract 18 from both sides. So that's going to give me negative 108 minus 18 would be negative 126. And then we want to divide both sides here by negative 6. And we'll get x is equal to, negative divided by negative is positive, so 21. Alright, I believe we're on our last chunk here. Pretest, okay. Alright, here we have used the following graph to answer these questions. So we have Party Supply Rental has many items that are available for rent. They charge a $20 fixed price and $5 per hour. So we have our equation here. And we said C is representative of the total cost and N is the number of hours rented. So this is like our C here, and this is like our N, or C of N technically, if we keep with our equation. Okay, so for 35, how many hours can you rent the cotton candy machine? And we're also going to go ahead and throw in here the interpolation, extrapolation, just so we have that as a good practice review. If we have $50, so $50, that is on my y-axis. So that means I'm dealing with interpolation, because I could find the answer from the graph. So if I look over at 50, it matches up here with 6 hours. So I can rent the machine for 6 hours. How much money will I need if I want to rent it for 2? So 2 is my hours here. If I go up, it looks like I'll need about $30. And again, since we found it on the graph, we're dealing with interpolation. If you want to rent it for 12 hours, well, 12, that's not on here. So since it's not on there, I know I'm dealing with extrapolation. So here I'm going to use my equation. So I have the cost is 5n plus 20. So the cost for 12 hours, I plug in here. Check out that equation, right? 5n plus 20, we're good. Okay, so 5 times 12, well, that would be 60 plus 20. So that would look like it's going to cost me $80. Well, that's the worst written 8 I've had in a while. There we go, $80. So not my best dollar sign. So 80. This one, if you have 100, how long? I see 100 is nowhere near here. So yet again, I'm dealing with extrapolation. So this time I'm getting the cost. So that means for my C of n, I would plug in that 100 and set it equal to 5n plus 20. Subtracting 20 from both sides, I'd arrive at 80 is equal to 5n. And then if I do 80 divided by 5, I'll get n is equal to 16. So it'd be 16 hours that I could rent it for. Alright. At this point, we're good to go. We should be ready for this exam. Again, we'll do another review in class as well. So, once you're good on this, we're in real good shape.